composed with Maeva Thibaud Combaz, and myself, Juliette. Unfortunately, as you can see, Thibaud is not here, but let me assure you that he worked really hard on this project, and he's apologizing for his absence. So today we choose to talk to you about the temperature, and more precisely, if there is a measurable temperature effect on Lérins biodiversity. To manage it, we will firstly introduce you the temperature effect on the marine ecosystem. Then we will see the method, that means the method for the temperature assessment and also the ecosystem richness monitoring. We will then show the results, that means the comparison between the temperature variation and the ecosystem richness variation. And we will conclude if there is a significant measurement, yes, no, and why.
So to start with the temperature change, I would like to just take a few seconds to precise that, of course, we won't speak about climate change. We wouldn't like to produce any errors or bad suggestions because the time and space scale are not the same at all. For us, we will work about just a few years of data and a very small location. And when we study the climate change, it's over hundreds of thousands of years. But we will use a scientific research about the temperature because the temperature raising can have a lot of different effects on the ecosystems. They can be abiotic factors influenced by the temperature because of the physicochemistry of the environment. So salinity, of course, current, waves. But also biotic factors can be influenced and directly on the species themselves and their function. For example, the reproduction can be impacted and then maybe the behaviors also. In our case, we will be in the Mediterranean Sea, and it's an important hotspot for the biodiversity. Even if the sea is less than 1% of the total volume of the oceans, it represents more than 7% of the total marine biodiversity. And this sea is quickly warming along the time. In our case, we will go, as you saw already, of course, in the Natura 2000 site called B and Cap d'Antibes, and we will focus on the Lérins island located here. And you saw already how it looked like, of course. So we will focus on this particular biodiversity site. Our question is, okay, there is a temperature rising in the Mediterranean Sea, but are we able to measure any effect in this site?
Now, let's pass to the method. As told you, Maeva, we know that there is a temperature increasing in the Mediterranean Sea, but how did we measure it for Lérins Island? As you can see, we took our data from Météociel, which is a website giving the sea surface temperature, as you can see on the map, and with this colorimetric scale, we can just report it, the color associated to the temperature. This is the species where we focus about. So we choose to take 3 months, July, August, September, because it's the months before the experimental manipulation on the sea. We did 4 measurements per month, and we took the years 2013 until 2018. Now, what about how did we measure the richness monitoring? I'm sure that you already know about that, but as you know, Lérins project is annual monitoring since 2012. There is 2 islands, Sainte Marguerite and Saint Honorat, and in all these islands, you have 60 stations all over the island. And to measure the biodiversity, we did a transect. A transect is 2 buoys, spacing from 10 meters and 3 meters from the bottom of the sea, and the biodiversity, different species, is counting.
Then, to present you our methods, in fact, we will go through 3 levels. The first one is about an indicator species that Juliette will present you. And just to remind what is an indicator species, it's a particular species whose abundance is depending on the particular environmental conditions. Then we will go through several species, and we will, in fact, group them, like you can see here, breams, races, echinoderms, and algae. And then if one or more of these groups are impacted by the temperature, We will go throughout the trophic level, because we can think that if one group of species is impacted, throughout the trophic links, other groups can be. For example, here, if the echinoderms, for example, increase with the temperature, the predator, like races, can increase also. And the preys, like algae, can decrease. And then, as a third level, we will go throughout the global biodiversity itself.
Now, let's pass to the result. I'm sure that you should wondering what happened on the Lérins Island about the temperature. Let's have a look. You can see on this graph the temperature over the years, each point corresponding to the mean of the temperature of each year. That means the 3 months of measurement and 4 measurements per month. As you can see, there is a quite variation between the years, because in 2013 we start almost between 25 degrees and 24 degrees, and we finish in 2018 almost at 27 degrees. That means that there is a significant variation of the temperature over the years. And in fact, with the ANOVA law, we can say that yes, there is a significant variation of the temperature of the seawater. As you can see, it's increasing. So in this stage of the study, it's really important to know that, because, okay, there is a variation of the temperature in Lérins Island, of the seawater temperature, So what's happened now? What is going on? Could we measure this effect, yes or not? So yes, there is a significant variation, Now, let's go to our biodiversity for the first scale. The first scale is the indicator species. We choose for you the hornet race, also called as Thalassoма pavo. This is an indicator of warming water. That means that our first hypothesis was if the water is warming, as we saw, maybe the abundance of this species will be increasing. We choose to put you the water, the temperature over the years there. Like that, you can always have a look between all the graph. So this is the temperature over the years that we already saw. And this is our famous graph about the abundance of hornet rate over the years. As you can see, it's increasing until 2015 and then decreasing. After a correlation law, we can say that there is no correlation with the temperature variation and the abundance of hornet race. Now, let's go to our second level, which is the trophic web. As told you, Maeva, we have the algae, the echinoderm, the races, and the bream. Let's go to see the algae species. As you can see on the graph of the abundance of algae over the years, you can see that the abundance remains quite stable. According to the temperature graph, we can say that there is no correlation with the temperature variation. That means that it's not significant. In other case, that means that we can't measure the effect of the temperature on the algae. Then let's go to the echinoderm. As you can see on the graph, with the abundance of echinoderm over the years, you can say that it's increasing until 2015 and then decreasing. After a correlation law always, we can say that there is no correlation with the temperature variation. So it's not significant. Now let's go to the races species. You can see the abundance of races over the years. It's increasing until 2015 and then decreasing. So you may maybe think what's going on. That means that there is no correlation with the temperature variation. So it's not significant. Let's go to our last, species group, which is the bream. So you can see that it's decreasing until 2015 and then increasing until 2018. After the correlation law, we can really say that there is no correlation with the temperature variation and the abundance of bream. So it's not significant. What can we say now in this stage of the study? It's really important because that means that we know that there is a variation of the temperature, but we can't measure the effects on the abundance of this trophic web result. That means that we can't go further and go deeper if there is some trophic link.
So after this middle scale, let's go for the last one, which is the global biodiversity. To measure the general biodiversity, we choose to quantify the richness and the evenness of the species. So the richness is the number of species present in the ecosystem, and the evenness is the number of individuals in each species. And because at that place we have both abundant and rare species, the better index to use is the Shannon-Wiener index that we represent on the ordinate axis here. And over the years, here, all the values are between 1 and 3, which is interpreted like a fair diversity over the years. And if you remind the previous temperature graph, and thanks to the statistical test, in fact, we couldn't conclude that there is a real correlation between the temperature variation and this index. So, in order to summarize all these results, we can say, first, there is a clear seawater temperature in Lérins. It's significant. Then, for the biodiversity, the indicator species that we choose is not really impacted, apparently, by the temperature. The groups of species that we choose and the trophic link is not clearly impacted also. And the global diversity seems to get the same result. So, to answer to our question, is it measurable or not, this temperature effect, we have to conclude that it's not measurable. But we try to go further and to ask why. First idea is our temperature data. Because, as Juliette said, we chose 3 months, and just the previous months before our diving. So maybe choosing another period in the year previously, or maybe a longer period, or maybe more data, could be more relevant. Because we don't know for each species or groups if there is a life cycle impacted, or if it's the previous generation which could be impacted also. Then about the spatial precision, because we get data of a large area close to the shoreline. But maybe at Lérins, the temperature is not exactly the same. So, of course, the better way would be to have the precise temperature of these islands. And, of course, we are only on temperature, but what about the other factors influencing the environment, like the rain, the wind? They can also make some variation that we are not measuring here. Then, another thing is a huge variability. I don't know if you mentioned it, but on the graph there is a huge variance. And all this variability can be explained by, first, we don't have any replicates per site. We did just one measure. Then there is a big artifact, which is the human itself, because we are in the environment and we can afraid the fishes. Then the human error itself, because sensitivity, we didn't measure any benthic organism, for example. The right identification in terms of brown or black sea urchin, I'm sure we didn't do the difference. And then, if you multiply the operator, of course, you can multiply the errors also. But as we know, the way was to learn, and apparently we still have to learn. And one more thing is about the conditions of the sampling, because depending on the weather, it can influence the turbidity, so the sensitivity of detection also, and maybe the presence of different species. So one suggestion that we have is for the following years, after the day of sampling, to note the weather. Maybe it can help the next student to understand or to have an idea about why there is a huge variability in terms of assessment. This is our reference, mainly for the introduction part. We can come back on here. And we would like to thank you all to bringing us in this amazing adventure. Also the ones who are not here today, particularly Thibaud, because it's a nice schema student and he worked really with us. And thank you very much for your attention.